Hey friends, welcome back to another session. We're going to talk all about the immune system and why young people may not be immune. And it wasn't that long ago that I was a 20-something. I remember spring break was amazing. Going out to the bars, to the clubs, things like that. I just want to provide a little bit of context about how the human body responds when it's infected with the SARS-CoV-2, which is known as the human coronavirus. So in this video, we're going to talk about the body's immune response and how the immune response is actually part of the problem. Of course, we need to mount an immune response, but the human body is not adapted to have some sort of coexistence or coalescence or, antibodies built up to surmount and tolerate the human coronavirus. And part of the pathophysiology, as I will share with you on the screen here, is actually an over-exaggerated immune system response through which young people are not immune to. So if you're young and healthy, it's not that your lack of immunity is part of the problem. Part of the problem in the pathophysiology, again, to reiterate, is an over-exaggeration of the immune system, which causes collateral damage. The analogy that I'm going to make here as we dive into some science and wait for a few more friends to get on is like if you have a mosquito in your house or a fly, and if you were to use a sledgehammer to kill that mosquito, you can imagine that while you might attempt to kill the mosquito, you're going to cause a lot more collateral damage. And that's part of what happens within the body. And we're going to review some data from bats showing that how bats actually coexist with a range of coronaviruses, including the SARS-CoV virus, is because they mount a very strong interferon response, which I'll get to and define what that is, but they also have a little bit of throttling on their immune system so that it's not throwing around a sledgehammer trying to kill a mosquito, which is kind of what happens in the human. And so it's not that your immune system is weak if you're young and therefore you're resilient to this. It's that if you get infected, your body doesn't know how to appropriately create an adaptive immune response. So the cytokine storm that is created both in your lung tissue and throughout the body that we're going to get into could actually lead to the pathophysiologic abnormalities that could cause you to end up in the ICU and have respiratory distress and pneumonia and eventually, potentially, hopefully not die. Now, this has happened to young people. So I just wanted to bring this up, and this video is not relegated to young people, but I do see some cavalier attitude. A lot of people going to the bars and going to nightclubs and trying to pretend that this is not really a big deal. And what that is actually doing is delaying how long we all have to be sort of on lockdown, because the longer that the curve doesn't start bending, the longer that we're going to be sitting here staying at home and not being able to go to work. So if all of us just cooperate, I feel like we can get to our lives again. So if you're enjoying this content, please hit that like button. That lets me know that I should do more videos on this. Tomorrow, we're going to talk all about cellular senescence. So today is Sunday evening, March 22nd. And I just wanted to come on here, so I just want to check in, make sure we're good. It looks like a lot of us are good. So let's dive into it and just talk about the immune system and talk about some lessons learned from other animals. So as I mentioned, actually, let me get to this slide right here because it'll just show you that, coronaviruses, by the way, are not going away. They're found in a bunch of different animals. They infect a lot of different animals, pigs, cats, bats. It's purported that potentially the way that we humans, that is, got the SARS-CoV-2 virus is through bats affecting cats, and then cats were at this market, and then whether we ate them, whether people ate them and then transmitted that way, or it was transmitted via breath, it's not really sure. But what I want you to realize is just because maybe and hopefully very soon, humanity will have solved the imminent, SARS-CoV-2 problem. But that doesn't mean that there won't be something down the road that could potentially be an imminent threat. So what I want you to take away from this as you're listening to this, even if hopefully you don't get affected by this personally or anyone you know or care about, hopefully does not get affected by this virus. What I want you to keep in mind is we always need to keep immunity top of mind. Over the years, I've made a lot of videos about the immune system, about immunity, and unless I weave in something like adiponectin and leptin and the immune response, most people just gloss over it because they're focused on keto and calories and intermittent fasting. But I want you to always keep in the back of your mind that humans are always going to be presented with foreign invaders, antigens, whether it's viral, bacterial, protozoal, parasitic, things like that. we are going to always be faced with this challenge. So immunity needs to be part of our lifestyle. So tomorrow we're going to talk about immunosenescence and how as we get older, that can be part of the physiology as to why SARS-CoV-2 can be problematic. But here's the lesson that I really want you to start sharing with your friends and family and talking about, because again, people think, well, I have a strong immune system, I don't get sick. And I believe me, 2 weeks ago, I had this cavalier attitude. And I was out and about, I was going to the gym, I was like, look, this is not that big of a deal. People are making this out to be a much bigger deal than it really is. And I've since changed my mind since diving into the research, because I realized that just because you have a strong immune system doesn't mean that you're immune from your own immune system's collateral damage. Again, for those of you just hopping on, we use the analogy that our immune system responds to the SARS-CoV-2 virus, also known as the novel coronavirus, the human coronavirus, kind of like a sledgehammer. If you had a mosquito or flies in your house and you tried to kill it with a sledgehammer, you're going to cause a lot of collateral damage. And ultimately, based upon some of the pathology reports from the SARS pandemic or epidemic back in 2003, and now some of the pathology reports from Wuhan and also Italy, it's the collateral damage, silly. It's the cytokine storm that's created from our own immune system because the SARS-CoV-2 virus, the novel human coronavirus, is so adept and adroit. It's so interestingly, it gets into our cells very readily, and it's very virulent. And so it's able to get in there, take over immune cells' metabolism, machinery, evade the immune system, and cause just an over-exaggerated, violent response. And so here's the thing that is on the screen right now. We're going to talk about bats. So bats, as I mentioned earlier, if you've been watching and with us for this live video for the entire length of time, I mentioned that bats are able, scientists have been studying bats for a long time because they're able to coalesce with these viruses. Just like we're able to coalesce with E. coli bacteria in our gut. Like if the E. coli bacteria in our colon was in our bloodstream, we would be dead. But we have this immunological barrier, we have immunological tolerance, so we're able to tolerate some of the bugs that live in and within us, right? Bats are the same way. So when bats get infected with the SARS-CoV virus, it's not called the human coronavirus, it's just called the SARS-CoV virus, they elicit an interferon response. So interferon is how your body and your immune system, it's a byproduct of your immune system. We'll talk about vitamin D later in just a moment. But interferon is an antiviral immunological byproduct, for lack of a better word. They elicit a very strong interferon response, and then they kind of, the best word is to say throttle their body's own immune system response. So instead of then also triggering interleukin 17, interleukin 6, and all the interleukins that us humans release, they release and they downregulate this inflammasome complex called the NLRP3 inflammasome. Now let me pause here, because many of you who have listened and subscribed to this channel for a length of time, you've heard of this NLRP3 inflammasome. This is a signaling hub. It's like a switchboard that when turned on, triggers all these downstream pro-inflammatory pathways. So again, when bats are infected with the SARS-CoV virus, right, which is the SARS virus that we're now affected by the SARS-CoV-2. It's a novel coronavirus, but it's very similar in terms of pathophysiology to the virus that bats coexist with. They have a strong interferon response, and then they immediately start to quell the body's immune system. Now that's counter to what a lot of people are talking about right now. You're hearing so many natural health experts talking about ramping up immunity, raising your immune system, all that. Okay, this is counter. How the bats are able to, deal with this again is to dampen immunity. And so again, I just want to correlate this back so it sticks in your head, because these terms are going to start to be convoluted over time. We're talking about SARS-CoV-2, we're talking about interferon, we're talking about NLRP3 inflammasome. Again, this is the switchboard that regulates a lot of pro-inflammatory signaling hubs. Basically, it's a hub, it's a transcription hub. And bats decrease this. Remember, if you've been following this channel for any length of time, you'll know the NLRP3 inflammasome and its link with nutritional ketosis. So ketones are able to downregulate this NLRP3 inflammasome. Let me just pause, take a taco time out. I'm not saying the ketogenic diet cures the coronavirus. I'm not even saying it prevents it. I'm just helping you make this stick, because many of you are interested in keto, and we have a natural beta-hydroxybutyrate is a natural NLRP3 inflammasome inhibitor. So hopefully human studies and animal model studies will be forthcoming, and possibly looking at how, whether it's physiologic levels of ketones or exogenous ketones, how they might be able to affect this signaling hub in animals when they're infected with the human coronavirus, the SARS-CoV-2. But we don't know that at this point in time. But we do know that beta-hydroxybutyrate is a natural NLRP3 inflammasome inhibitor. So again, bats can live with this bug because they have a strong interferon response. They immediately trigger this hub, which brings down the collateral damage. So instead of hammering this mosquito with the sledgehammer, they're using like a fly catcher, fly swatter, right? So there's not as much collateral damage. They still have an immune response, but they're not breaking their own tissue in the process. So here's a visual for that. Sorry for not changing the slides. And let me just get a just quick little shout out. If you all are digging this content, please hit that like button. If you're watching the replay, please leave a comment. This is how I know if I should do more videos like this. Again, we're just doing a little physiology update. I feel compelled to do this because about 10 days ago, I was kind of lackadaisical about this whole coronavirus thing. And since diving into the pathophysiology, I've realized that I'm not immune to this, nor any more or less than anyone else, right? Because the human body is not equipped to coexist with these novel viruses, and a weak immune response is not necessarily what is killing people. It's an over-exaggerated immune response. Let me just, again, read this out for you, because some of you will be listening to this. Bats respond to RNA viruses, just like what we're talking about here, by inducing a robust interferon response while controlling an over-exaggerated pro-inflammatory response, thus limiting the virus-induced immunopathology as observed in humans infected with those viruses. So the immunopathology is the cytokine storm that you've been hearing about. This is the release of interleukin-6, of interferon gamma, of all these different immune cells. Okay, so on your screen right now is the visual about how the bats are able to be infected with the SARS-CoV virus and able to kind of mitigate that by quelling this. Now, here's a visual for all of you watching right now about the transmission from this zoonotic virus, meaning that humans are now being exposed to pathogens that are normally found in animals. And so I just want you to be aware of this transmission. And again, this is just a mental sticky note. Okay, hopefully we'll get the SARS-CoV-2 and this COVID-19 under the wraps pretty soon here throughout the world, but it doesn't mean that we should just let off the gas pedal and forget all about our immune system when this is a thing of the past. We're always going to be exposed to viruses. These things mutate, they cross species, and so I think we're probably, hopefully, not in our lifetime hear about other coronaviruses, but we might. So again, things that you're listening to now are not only applicable in this imminent, pandemic, they will be applicable hopefully down the road. So I just want you to remember these things, because I think it's important that we remember these. On this slide here, what you're going to see is the different animals. So transmission from cats to other animals, from pigs, dogs. There's, I think, 60 to 90 characterized and well-defined coronaviruses. But the human, SARS-CoV-2 is this novel one that we're dealing with right now. Okay, so let's get into the pathophysiology, and I don't want to bore you with a bunch of complex jargon terms and medical terms and things along those lines. But again, I just want you to realize and spread the message loud and clear to people. All of our lives will return to normal faster if we all participate. I'm normally not one of these people that follows the crowds. I like to, when everyone's going out one door, I see the exit door. I'm the person that deviates to the left. But in this situation, friends, we all need to work together to socially distance ourselves, to really bend this curve so our lives can go back to normal. It really kind of pisses me off when I see so many people are jet setting around the world and living their lives as though it's pre-coronavirus. That, even if you're not symptomatic, you could be spreading it to other people. And that is just creating more alarm, more fear, more deaths, more cases. And our lives are not going to get back to normal until we all kind of do this and hunker down together. So again, I'm not trying to spread fear. I just want you to realize that we all got to participate, man. We're in this together. We're in this together. So check this out. These are quotes from a 2009 paper It's generally accepted that the host response is responsible for many of the disease manifestations in infections caused by coronaviruses. All right, let me just pause and kind of decipher and break that down. What does that mean? It means that the collateral damage created by our own immune system trying to protect us is what's causing the pathophysiology or the disease etiology. So it's our immune system in its how should we say, zest or zeal or exuberance. Our immune system's exuberance is part of the problem. So again, you young people jet setting, going on spring break, traveling all around, it's not that you have a weak immune system. It's that when you are infected, your immune system is creating so much collateral damage that it's effing up your lungs, your kidney, your heart. If you look on the pathology reports and the cause of death in some of these people, it's myocarditis and inflammatory issues associated with the cardiovascular system because of the cytokine storm that's created from our own immune system. So again, this narrative that you have a strong or weak immune system, that isn't necessarily always the case. Okay, so another quote here, right, from this paper that you might find interesting. Host efforts to clear a coronavirus infection results in some level of tissue destruction. Okay, so translation, as your immune system is trying to get rid of this bugger, it's creating collateral damage. So again, youngins, you're not immune to this stuff, man. It's a really strong, robust immune system could actually contribute to the problem. Okay, so let me this last quote here for all of you listening in iTunes. You're going to have access to this PDF. Okay, it has been postulated that an overexuberant cytokine response contributes to a poor outcome in patients with SARS-CoV. Okay, so all right, let's get into the mechanisms here, and then we'll talk about what we're going to really kind of drill into tomorrow that I think will be hopefully important, relative, relatable. So we have this over-exaggerated immune response, which is how, we see, like, we hear about these case reports where there's an 18-year-old, a 24-year-old, a 30-year-old that's healthy, that is on a ventilator, that's been intubated, that's in the hospital, and they have really severe pneumonia and they might die. You think, well, how can this really happen? Well, again, it could be the collateral damage, but then we also hear that majority of the fatalities are individuals that have comorbid conditions, hypertension, cerebrovascular and cardiovascular disease, diabetes, history of cancer, a recent major surgery, things along those lines. So there's this kind of spectrum where you have an over-exaggerated immune response and then immunosenescence. And we're going to talk all about immunosenescence and really what that is tomorrow. And on Tuesday, a wonderful interview with Jeff Grimm. So I just want to give a small plug. Please, if you're not subscribed to the channel, subscribe to the channel. Share this with a friend or family member. Let them know that we're covering this very extensively. And what we're covering through this whole COVID-19 pandemic is insights that people are not seeing on major media sources. So I don't watch the news, but I get reports daily from friends and family. And my mom just called me. She's like, Mike, you did that video 2 weeks ago that showed that men are more susceptible and more of the fatalities are in men. CNN just talked about that yesterday. And I was like, I know, I'm not saying that I'm ahead of the curve necessarily at all or super smart. I'm not saying that. I'm just saying I've been diving extensively into the clinical characteristics and case findings. And I want to share those with you so that you're more armed, because sometimes the media, there's a lot of talk about hand washing and social distancing, which is great and important. But on this channel, we like to dive into some of the details. Okay, so let's talk about how this virus can harm you. And the pathophysiology. So I shared this on Instagram earlier. Just wanted to give you an insight about this because, again, a lot of people are promoting essential oils, vitamin D, vitamin A, which, by the way, vitamin D does affect the interferon gamma and interferon genes. And so this is why, if you want to know about the mechanisms, when people are talking about, well, why do you take vitamin D and vitamin A? What's the deal? Well, remember how bats are able to surmount this virus is by having a really strong interferon response. Interferon is our body's primary innate way to circumvent virus infiltration. So that's why a lot of people are talking about vitamin A, vitamin D. Small little plug, we do have a supplement brand, Myoscience. We have a super clean vitamin A and vitamin D product. Again, I just want to let you know that those compounds cannot cure, prevent, or treat any diseases. They're just natural ways to support your body's own immune system health. So links are below for that. But what's interesting is this virus, as we've talked about before, uses this protein on its cell membrane, its exterior surface, called the spike protein, and latches onto your own endogenous receptors called the ACE2 receptor, and that's how it's able to get in. And so it's really, this virus has a very easy propensity and lends itself to getting into your cells, and not only just the respiratory tissues. This is another very important point. We're going to talk about it at length this week so that you understand this. These individuals are not just that are infected with this disease are not just dying from upper respiratory tract infections, because this virus, once the viral load increases, it's going into the brain, it's going into the heart, it's going into the kidneys, it's going into the thymus, it's going everywhere, and it's affecting all sorts of different tissues. So it's not just relegated to the lungs and causing pneumonia, it's going everywhere. So again, young jet setters that are running around thinking you're immune to this, you need to understand that this sucker, your body doesn't have the mechanisms in place to create antibodies to neutralize this and kind of sequester this like it does for other viruses. So just want you to know that. And what you're going to see here, I think it's in the yellow, depletion of immune cells. This has to do with the immunosenescence. And what I'm going to have shined over here, so we've talked about young people and people in general, humans in general, have this over-exaggerated response within their immune system. Bats are able to mitigate that by upregulating this transcription hub called the NLRP3 inflammasome. But on the flip side of that, the reason why you see a lot more mortalities and severe cases in the elderly and old and individuals with disease comorbidities, and this is, I think, a very important point. I've been criticized a lot on Instagram for talking about type 2 diabetes, hypertension, for talking about diet and lifestyle. But as so I'm 37 years old biologically. You all know that I recently did my DNA age, which will tell me my epigenetic age, which will give me my biologic age. So there's a disparity between your chronologic age, which is your actual age, and your biologic age. Some people are biologically younger than their chronological age. Other people are biologically older than their chronological age. Why is this important? Because in the context of heart disease, high blood pressure, cardiovascular related comorbidities and cerebrovascular disease and strokes, and diabetes, your cellular aging is upregulated. So your cells are older than your chronological age would suggest. And though in those individuals, they're more susceptible to disease severity. And again, so this is when people say, well, this young, otherwise healthy 21-year-old is intubated and has all this pneumonia from SARS-CoV-2. Well, okay, do they have prediabetes? Do they have hypertension? A lot of millennials now don't even know that they have prediabetes, and they do. So metabolic health accelerates your body's aging of your immune system. We're going to talk a lot more about this tomorrow. I just want to leave you with this tip because my camera's beeping at me telling me that the battery is getting low, which is a damn shame. So, because I want to get to some of your questions. But I want you to realize that not all of you are biologically, if your chronological age is 31, biologically, you might be 41, you might be 26. So unless you look at your epigenetic clock, you don't really know. And so that's why we're seeing this disparity in age, because what the research shows is that in the mortality and in the severe states, not only are comorbid conditions common in the more severe disease states, but individuals that have immune alterations and a low CD4 and CD3 and CD8 T helper subsets. And this has to do with immunosenescence, which is the way to kind of quantify and characterize accelerated aging within the immune system. What I will do is I will go back and update this video and link to one of the videos where we talked about biologic age and epigenetic clocks. We talked about the Horvath clock. Many of you know that I love DHEA, that I love metformin and berberine and these different natural compounds because these were some of the things that were used in Steve Horvath's study that was published in September in 2019, this last year, that showed that you can reset your thymic atrophy. Your thymus gland is an important immune cell. It's an immune organ that's involved in a lot of different immunological functions, and the atrophy of your thymus gland is linked with your health outcomes. So that's coming up tomorrow. I really hope you can join us for that. If you do, or if you want to learn more about that. I mean, again, this is where lifestyle and diet comes into this picture, because again, I've been criticized so much on Instagram for continually talking about blood sugar, fasting, time restricted feeding, how that's important in this narrative. And it has to do with what you're seeing on your screen right now, where there is increased disease severity and mortality in individuals that have immunosenescence, that have a compromised immune system. And metabolic disorders exacerbate immunosenescence. So this is all related, friends. I know you don't catch diabetes from going to Sam's Club or to Costco or sitting on an airplane, but guess what? If you do catch this coronavirus, you betcha that your prior and previous lifestyle choices will determine how your body will respond to this bug. And so I'll end with that. I want to thank you all for being here. It's so awesome to connect with a lot of you friends. Gosh, we have close to 400 of you on, which is really cool. So just super grateful that you were here. Again, if you enjoy this content, I would be so honored if you can hit that like button. If you're watching the replay and you enjoyed it, please comment below. Super excited to share this information with you guys. I think together we can really impact a lot of people. And so again, I'm encouraging social distancing. I had, dinner plans last night that I canceled. I've been, really my wife and I and our family has been just together, just the three of us, trying to get outside and get sunlight, but not be in closed, confined public spaces where we can get exposed or expose other people. And I think it's important that you do the same, because I want my life to get back to normal. I know you do. And so I think we all gotta work together. So as always, honored that you're here. Have an awesome day. Take care of yourself. Hopefully you found this helpful. We'll catch you soon. Sorry that I didn't get your questions, guys. I promise I'm going to go back and relook at this and answer some of your questions. So until then, have a good one. Talk to you soon. Bye now.